Okay, so now that we've talked about our identities, what we're going to do is we're going to try to use our identities to write equivalent expressions, right? So here's our examples. So examples, and the directions are use our identities to obtain an equivalent expression involving sine and cosine, and then simplify. So what this basically means is that we are going to make sure that we only include in our final answer sine and cosine. We don't want any secants, cosecants, tangents, cotangents. So that's our examples. So I have a few examples for you. So as you guys are following along, you probably want to have the identities out. So that way we know what we're doing. So here's our first problem. Secant of theta cotangent of theta times the sine of theta. Okay. Everything can usually be brought back into sine and cosine. That's why we have that. So secant's reciprocal is cosine. So this is 1 over cosine of theta. Cotangent is made up of cosine of theta all over sine of theta. And then sine of theta, we're going to just leave as sine of theta, all that one. And I'm just going to put it as over 1 because I notice that they're all fractions. Well, if I notice that this cosine and this cosine will cancel each other off, this sine and this sine will cancel each other off, and so what will I have left? Big old number 1, right? That is as simplified as possible. My answer does not involve sine and cosine, which is perfectly fine. But we have simplified everything. So let's go ahead and try number 2. So cotangent squared theta times 1 plus tangent squared theta. So if you want to try pausing the video and trying this one on your own, that's great. If not, let's try it. For this problem, what I'm going to notice is the cotangent squared theta. I'm first going to multiply this out. Okay, so I'm going to multiply this guy here and this guy here. So cotangent squared theta times 1 just stays as cotangent squared theta. And then this will be plus cotangent squared theta times tangent squared theta. Now, what do I know? Cotangents and tangents are reciprocals of each other. Anytime I multiply the reciprocals by each other, this will give you 1. And don't forget the little plus sign in between. Cotangent squared theta plus 1, that is a Pythagorean identity, and that is equal to cosecant squared theta. Now I want to involve sine and cosine, so that means that this is equivalent to 1 over sine squared theta. Now, in my directions, if I said to simplify the expression and leave no quotients, right, no fractions, this would be our answer. But I want to just involve sine and cosine, so we're going to use this one, right? If you wanted to change cotangent into cosine over sine, kind of like what we did over there, that's something else that we can do. All right, let's try another one. Like I said, if you want to go ahead and pause the video once I have this up, you can try it on your own. So we are going to multiply secant of theta minus 1 times secant of theta plus 1. So hopefully what you notice is that it kind of looks like two binomials. What would we do? We'd multiply them. So multiply this guy with that guy. So I get secant squared theta. Secant theta times 1 is just secant of theta. negative 1 times secant. So minus secant of theta, negative 1 and positive 1. Oops, that's not supposed to be positive. Negative 1. What are we going to notice? That these two guys are opposites of each other, so they are canceling out. So I get secant squared theta minus 1. Again, using your Pythagorean identities, I know that that is tangent squared theta. If we want to include only cosines and sines, this is the same as this. Right? But like I said, if we didn't want to put fractions, we'd leave our answer like that. Just with sine and cosine, that is our answer. All right, let's go ahead and try a fourth one. So for this one, we haven't used our negative angle identities yet. So tangent of negative theta all over secant of theta. So the first thing that I'm going to do is I'm going to pull out that negative sign. So using my negative identity theorem, it says that it's going to be tangent of theta. Go ahead and multiply it by a fraction. I'm going to break it up. So 1 over secant. I'm going to change tangent to sine of theta all over cosine of theta. I'm going to change secant to cosine of theta over 1. What's going to happen is the cosines are going to cancel away, and I will just be left with negative sine of theta. If I want to bring that negative back in, I can, or I can be done right here. All right, let's try one more, just so we can say we've done it. They're all a little bit different. I could show you lots of examples, and they'd all be different from each other. But let's try this guy. 1 minus sine squared theta all over 1 plus cotangent squared theta. So go ahead, pause the video, try thinking how we can simplify this problem in as few steps as possible. Okay, so the first thing I notice is whenever I see 1s in trig squared, I gotta think of my Pythagorean identity. So 1 minus sine squared theta actually is an identity, and that is cosine squared theta. 1 plus cotangent of theta is the same thing as saying cosecant squared theta, divided by. And what I'm going to do is I'm going to divide cosecant. I'm actually going to write it as the sine squared theta. Division is the same as multiplying by the reciprocal. And so you have cosine squared theta times sine squared theta. There's nothing else I can do, no other way to simplify it, just like that.